Section 1.2, Data Classification. In our previous YouTube video, we were discussing the difference between numbers and data. Today, I'd like to discuss different types of data and how it's classified. Qualitative data and quantitative data. Qualitative data describes the qualities, it's in the descriptor, or the characteristics of it. We don't have numbers for qualitative data. It's a property we're looking at. Attributes, how we identify it. It's often open-ended questions. How large is it? How small it is? How long will it go? How big is it? How often does it happen? We don't have hard numbers for this, but it's a describer, so we can look further at it. For example, if I classified all the different cars in the buried parking lots at the school today, I could see examples of how many red cars there are, how many blue cars, how many green cars, how many yellow cars, how many orange cars. And that doesn't tell me much by itself, other than I have descriptors of different colored cars. But I may want to explore further and say, why are people buying these colored cars of different colors? Is there a rationale behind it? A bookcase here. For qualitative data, I could describe it. Made of wood, built in Italy, deep brown, it's got gold knobs, smooth finish, made of oak. It could be made of metal. It could be made of plastic. And see, there's no ranking this. Made in Italy, or made in Sweden, made in Switzerland, made in the United States, made in China. Deep brown, golden brown, white, unstained, made of oak, made of pine, made of mahogany. We are describing this. We're not giving a rank to any of these, and we cannot add any of these up. We can't add oak to pine to mahogany. We can't add Italy to Switzerland to Sweden to China. We are describing it. There's no numbers here. Not the size, not the shape, or even the cost. We can't calculate this, but they're descriptors. Examples of qualitative data. Socioeconomic class, from lower class, lower middle, upper middle, and upper class. Opinions. We've seen these before on Yelp, YouTube, as well as Uber. Student status. You're a freshman, sophomore, junior, senior, or graduate student. There's no ranking this. Now, we want to know how many there were. That's ranking, but we're not talking about the size of it. We're talking about the descriptor. What year is a person? Food groups. Meat, dairy, carbohydrates, vegetables, fruits. All important. We're not talking about how many calories each one has on average or how many one's consuming. That's quantitative, but right now we're just describing it. Car styles. Sedans, coupes, compacts, SUVs, minivans. These are 5 different kinds of car styles. We can't rank one as higher than the other or more important than the other. We can't add these up. Personal preferences vary, but we're just describing the different types of cars. So when we're looking at qualitative data, there's no method to sort it. We could say alphabetically, but beyond that, there's no real rationale to why to sort it. Should meat come before dairy or carbohydrates when we have a list? Does the sedan come before compact or SUV? People, you may want to classify socioeconomic status as lower class being at the bottom, upper class being at the highest. But why? If we're talking about volumes, then that wouldn't use that ranking. If we're talking alphabetically, a different ranking. But see, there is no right or wrong because it's non-numeric. There is no certain order to put qualitative data in. Quantitative data uses numeric information when we look at these traits characteristics. It can be measured. It uses numbers. It uses hard values. It can be calculated. We can add together. We can multiply it together. We can divide. We can either also express it mathematically the height of something or someone, the distance from one place to another, the circumference of someone's waist, how much water is required, how much flour is required for baking. These are numbers we can add, we can divide. If I know a loaf of bread requires 400 milliliters of flour, I'm going to make 2 loaves, I'll need 800 milliliters. It's something I can multiply together. I can base it on something and then double it, triple it, even use exponents, but it's numeric, and I can use a calculation with it. Examples of this include age. Dates. I've got some famous dates here. 4 BC is the year Christ was born. 20 AD, the year he was crucified. 1066 AD was the Norman invasion of England. 1215 AD is when the Magna Carta was signed by King John in England. 1517 is when Martin Luther put his 93 Theses on the church doorsteps. We look at these dates because I can subtract them from our current date to say how long ago that was. That's quantitative. Distances, how far is something? How long is something? I got atomic masses here. Now the atomic mass, the weight of one atom of hydrogen is 1, helium's 4, carbon's 12, neon's 20, uranium's 235. But if I'm given how much hydrogen there is, let's say I've got 5 hydrogen atoms and 1 carbon atom, well, I would add 1 times 5 for hydrogen plus 112, that's 17. I can actually quantify that. I can add to it. Number of legs in arthropods, such as spiders, crustaceans, insects. Arachnids have 8. I can count. I can see how many legs there are on an arthropod, which means it has an exoskeleton. If it has 8, it's an arachnid, a spider or a scorpion. If it has 6, it's an insect. If it has 10, it's a crustacean. 14 is an isopod, such as a roly-poly. Chilopods, such as centipedes, have anywhere from 30 to 354. So I know by numerically looking at this, I can classify this. I can calculate it. I can find a scale to it. I can draw a scale of the number of legs on different types of arthropods. Now I can also look at differences. Now, when we talk about statistics, there's 4 different types of data between the qualitative and quantitative in the whole. There's nominal data. Notice I said nominal. The letter N is a nominal and the letter is a name. This is the simplest. These are just giving a name to something. These are true qualitative descriptors. You can't calculate anything with this. It's just a categorization. I've got a couple examples here of nominal data. Type of wood: oak, mahogany, pine, walnut, cherry. I can't add cherry to pine and mahogany. I can't get a numeric number. I'm just classifying it. House structure: either be a ranch, a bi-level, or a 2-story. Now, if I had number of square feet, I could classify that as quantitative, but I don't. I just want to know different structures of the house. There's ordinal data. And again, just like with nominal has N for name, it's just a name, nothing more. I have ordinal data, and O is an order. This is when we put something within a certain order, from lowest to highest, from smallest to largest, from happy to unhappy, which is I've got here. It comes from the ordinal, it comes from the order, which is what the purpose scale is. You see these all the time on Yelp, or if you have you like or dislike a YouTube video, or even an Uber Eats. You can classify how happy or unhappy you are with it, and then go from excellent, good, fair, average, fair, or poor. And there's an order to this. Obviously, excellence at one end and poor is on the other. And you put an order to this. There's no numeric amounts. Now we can add up the number of excellence, number of goods, number of averages, but by itself, we're only looking at how we feel classified with this information. Now, that was qualitative data. Now we're talking about quantitative data. There's two types also in quantitative data. There's interval data. This is we go an interval when there's a space between one and another. If we know how warm it is, or what the temperature is, we can say it's 50 degrees. Well, we can scale that. What's 10 degrees cooler than that? 40 degrees. 10 degrees cooler than that? It's 30 degrees. We have a scale between the two. There's an interval between this, or counting as a space between. Examples that include like time, 10 o'clock to 11 o'clock, 11 o'clock to 12 o'clock. There's an interval of 1 hour between each one of these. Temperatures, 20 degrees, 30 degrees, 40 degrees. We have an interval for those. pH levels, for how acidic or basic something is. The higher it is, the highest is 14, the lowest is 0. A pH level of 7 is water, so below water is more acidic. Above water, higher number, the more basic it is. And we classify these. Richter scales. Richter scales for earthquakes, from lowest to highest in terms of how severe an earthquake is. Now, the reason I put pH levels and Richter scales on here is because these are not traditional linear numbers. These are logarithmic numbers. The pH of 5 has 10 times the level of hydroxyl ions than the pH of 4. It's actually 5 zeros. pH of 6 is not 1 time more powerful than pH of 5, it's 10 times more. The pH of 7, there's a difference between 7 and 5, that's 100 times more than 5. pH of 8 has 3, that's 3 zeros. 8 minus 5 is 3. It has 1,000 times greater hydroxyl ions, which makes it more basic. So, same with Richter scale. As a Richter earthquake at a Richter scale of 2 is 10 times worse than a Richter scale of 1. Earthquake of 3 is 10 times worse than a Richter scale of 2, and 100 times worse than a Richter scale of 1. Again, that's the number of zeros. And the thing I want you to understand here is not just linear, as in temperatures or time. It can also be nonlinear, but there is a space between. There's an interval. Then there's ratio data. Ratio, meaning we're looking at a numerator and a denominator ultimately. There's a ratio between the lowest and the highest. The only difference between this and interval data is it has a meaningful zero. And this is not a difficult option to understand. It means 0 is a potential answer. I've got a graph here. Let's say we've done a poll here. Number of days per week a person exercises. Let's say I polled 100 people. And 10% of them exercise 0 days. So that's an answer. They can exercise 0 times. They exercise 7 days, we got 3%. The most common, 30%, which is 4 days. But the 0 can be an answer. So the ratio data has 4 components. And it's everything we've talked about already. It's measured. It's ordered, like ordinal data. It's equidistant, like intervals between each space, but also has meaningful 0. That's the difference between ordinal data and ratio data. It has a meaningful 0. It can have a 0 for an answer. I've done a little map here to understand this, the quantitative and qualitative differences. We have data. And if you look at the bottom here, what I've got here, is it measurable or non-measurable? We can't measure oak or wood or plastic for that cabinet. It's non-measurable, so it's qualitative. And then can it be sorted? If it cannot be sorted, it's nominal. This is the name. If it can be sorted, such as those emojis with smiley faces and frowny faces, we can put some order. That's ordinal data. Remember, ordinal. You just give it a name, it's nominal. Now, if it is measurable, it has no meaningful 0, it has an interval. And a good example of this for Quantitative data that has no meaning equals 0 is the height. No one is height 0. Someone could be 4'10", some could be 5 foot, some people are 5'6", some people are 6'6". That's quantitative. I can add those heights up, but no one is height 0. So there's no meaningful zeros there. So that's an interval. A meaningful 0 could be the temperature. It is 0 degrees. There are 0% of people. There are people that exercise 0 amount of times per week. Or we could say there's 0 people that exercise per week. I've also separated this way for you to have a better understanding. Qualitative data. We have all data. Qualitative data, which is on the left here, can be, again, looked at nominal, ordinal. Now notice both nominal and ordinal have named data, but the ordinal data also has ordered data. When we look at quantitative data, which is ratio interval, the interval not only is it ordered like ordinal data and equidistant, the ratio data is ordered, equidistant, and has that meaningful 0. We can have a 0 for an answer. In this last slide, I want to classify, again, the different levels of measurement based on qualitative and quantitative data. Nominal. A good example is eye color. This is only named blue, green, red, yellow, orange. No color can be ranked above one another, but they're named. Ordinal. This is a level of satisfaction, for example. Looking at the Yelp review, or the YouTube review, or the Uber Eats review, from emojis that show very happy to very unhappy. Not only is there names to it, but there's no order behind it. Interval data. Interval is numeric, but it has a space behind it, between it, but it cannot have a 0. A good example of this is the height of an individual. Someone could be 4'10", someone could be 5 foot, someone could be 6'6", someone could be 7 feet. And that is measurable, but there is no one that is the height of 0 feet or 0 inches. So we have an interval between those heights. It's a name, the height. We have an order. It could be from the shortest height to the tallest height. But again, there's no 0 height. Ratio data. This has not only a name and an order to it, as well as the interval, like an interval data, but it has a meaningful 0. While I cannot have a height of someone who's 0 inches or 0 feet, I can have how often someone exercises as being 0 times, all the way through 7 times, as in the previous slide. Keep these in mind that each one builds up on the previous one. All ratio data is interval data with meaning 0. All interval data is ordinal data with an interval as numeric. And all ordinal data is named data that you can put in an order. If you can't put in any type of order as non-numeric, it's simply nominal data.